In this video for section 14.2, we're going to talk about how to write an equation for a linear relationship between two quantitative variables. And if our equation consists only one independent variable, we can call this simple linear regression. Later on, we're going to write equations that have multiple independent variables. But in this video, we're just going to have one. Sometimes this is called finding the line of best fit for the data. So you'll remember from algebra that we write the equation of a line in y equals mx plus b form, where m is the slope and b is the y-intercept. M is always multiplied by x and b is the number that's by itself. In MyLab and Minitab, we're going to write this a little bit differently. We write the constant term first, so we switch these around, and then we use b0 instead of b and b1 instead of m. So the equation looks like this. Y equals b0 plus b1 times x. So it's important to recognize that this is the same thing, just written a little bit differently, and that the slope is always the number in front of x, the y-intercept is always the number by itself. And we also want to remember from algebra what the slope and y-intercept tell us about the situation. Slope is the average rate of change in y for each 1 unit increase in x. And so, for example, if I have a slope of 12, that means that for each 1 unit increase in x, my y value is going to increase 12 units. A negative slope means that it decreases. So for each 1 unit increase in x, my y value will decrease 12 units. Y-intercept tells us the y value when x is 0. And depending on the context, this may or may not be meaningful. It just kind of depends on the situation. So we have some different ways that we can draw lines through data. The line of the best fit is going to be the line where the total distance between the points and the line is minimized. So Minitab is going to find this equation for us, so we don't have to worry about this too much, just to kind of be aware that what Minitab is actually calculating is it's calculating the equation of the line where these distances from each point to the line is the smallest. That's what the line of best fit means. So earlier we used a formal hypothesis test to determine whether the correlation coefficient was significant, and we can also use a hypothesis test to determine whether the slope is significant. My null and alternative hypotheses will look like this. My null hypothesis is that the slope is equal to 0, and my alternative is that it's not equal to 0. Remember, null hypothesis has the equality and alternative has the inequality. We're using this Greek letter beta in place of b. Remember, we did the same thing for the r. We used rho, Greek letter rho, which was that funny looking p. So here we're going to use beta for b. And so we're saying beta 1 equal to 0, beta 1 not equal to 0. And as usual, we're going to use Minitab to calculate the p-value and use the p-value to decide whether we reject or fail to reject the null hypothesis, and that will be whether or not the slope is significant. So we're going to look at this example here. We have our same situation that we had in the last video with our distribution company, and they want to know about the relationship between sales and number of years with the company. So we want to compute the regression equation, we want to interpret the regression coefficients, and we want to test the regression slope coefficient for significance. So let's pull up our data here. So what we're going to do is we're going to go to Stat, and then we go down to Regression. And then in the next menu, we click on Regression again. And then we click on Fit Regression Model. Now what I do in this window is I put my y value, what I want the y value to be in the responses box, and I put what I want the x value to be in the continuous predictors box. So I want my y value, or my y-axis, to be the sales, and I want my continuous predictors, my x, to be the years with the company. So I'm going to click on select the one I want, and then click on Select to put it in the box. So I'm going to put sales in the responses box and years with Midwest in the continuous predictors box. Then I click OK, and then here's what it gives me. So it's giving me my regression equation here. There's a lot of stuff in this window. There's my regression equation. So my equation is sales equals 175.8 plus 49.9 times years with Midwest. So this years with Midwest here is my X, and then my sales is my Y. So I'm going to write that equation down first. So it's going to be Y equals 175.8 plus 49.9 X. And so on the homework, it's going to have this equation, and then you're going to fill in boxes here for the slope and the y-intercept. So that's the regression equation. Now for thinking about what the interpreting the regression coefficients. So what are the slope and y-intercept in this context? So we'll start with the slope. The slope is the 49.9. And so what that is that means for each additional X or each additional year working with the company, the average sales increases 49.9. So for each additional X, the Y increases because it's positive by whatever that slope is. And the intercept, the y-intercept, but a lot of times in these problems you'll just see it called the intercept. That's the 175.8. And that means that when X is 0, or when number of years with the company is 0, these sales are on average 175.8. So that's what the regression coefficients are. Now looking at testing the regression slope coefficient, I'm going to go back to my mini tab here. So when I look in this coefficients box, I see t-values and I see p-values. So my t-value that I'm looking for, what I'm testing is the slope, and so I'm looking for the years with Midwest. The constant is the y-intercept. So kind of going back up to here, the 49.9, that's what I'm looking at because I'm testing the slope for significance. And so the 49.9, I see a t-value of 4.75 and I see a p-value of 0.001. So I would enter those into MyLab. I'll write them down here. So I had a t-value of 4.75 and a p-value of 0.001. And then, of course, I'm using alpha of 0.05. So compare my p-value to alpha. Since p is less than alpha, I can reject the null hypothesis. So that means that I do have evidence that the slope is significant. So a couple more things that you're going to need when you're doing the homework problems. First is that the homework is also going to ask you to test the overall model for significance. And so if you scroll down a little further, you see this analysis of variance table, and you're looking at this regression top row. It's giving you the F value and the P value. So for the overall model significance, this is the F value and P value that you would use. When you're just writing about if the slope is significant, you're using the t value and p value in this coefficients box. And lastly, one last thing that you're going to need is in this model summary box. So it's going to ask you for what's called the coefficient of determination. And that is this r squared value of 69.31%. So not the adjusted and not the predicted, so make sure you're looking just at the first r-squared value, 69.31%, and that's called the coefficient of determination again. So I'm going to write that down. And so that number from Minitab was 69.31%. And what that tells you is it tells us the proportion and I'm going to underline this word proportion because you're going to need it for the homework. It tells us the proportion of the total variation in sales that can be explained by the variation in time spent with the company. So obviously there's going to be some variation just between people. Like you could have two people who have both worked for the company for the same amount of time. That doesn't mean they're going to have exactly the same amount of sales. So there's some variation there. But we're saying that almost 70% of the total variation in sales can be explained by variation in time spent with the company. And lastly, what you're going to need to do when you put this into the homework is we have this as a percentage. You're going to need to enter it as a decimal, rounded to 3 digits after the decimal point. So that is going to be 0.693. So that's what you would enter into MyLab for the homework.